Hey everyone, this is my next part for the answer tutorial regarding C++ and asteroids in OpenGL. And I started creating or started thinking about how to do the vector handling we will need for later parts. So that was most of my research in the last 2 days. And today I look forward to getting most of the legwork done that we still have to do, like class creation and registering stuff. I'm not too sure if we're going to touch what's currently in the main yet, like copying that around and moving that to the correct place. I'm not really confident enough to do that yet, but we'll get this list smaller. And next time I'm going to talk about how I'm going to do the vector handling, like intersections and collisions and working with vectors. I have some class concepts done, but the actual programming will most likely be in a separate part of this enter tutorial. So next thing on our list is creating a class for our player ship, and probably creating a class for asteroids. That was not my intention. Okay, so we're going to add a class. Um, I just noticed you can't see in the recording, you actually can't see the Visual Studio wizard like the one that creates the class for you. I'm not too sure why, so I'll be figuring that out as well sometime. As the class name, we're going to use a player ship. Um, and the bases, they're like the stuff we're inheriting from is called um, game object, right? Game object. Okay. Nice. That's pretty fucking stupid. So why exactly does the wizard create a layer that doesn't work? Um, yep. I'll check that out. So where's the game object? I saw that somewhere. Okay, let's close stuff we don't need. We don't need the main. We don't need the game board currently. We don't need the point because that's pretty much done. We don't need a well, the rest we need probably. So game object. Okay, that's a simple class. And the declaration is class playership public game object. So I'm not too sure why that's not working as intended. It's not a typo. Um, so yeah, what? I'm looking at the tutorial right here, and it has a public and a protected section. And we are deriving a class that has class rectangle, public shape, and it just extends to public. So I don't know, we included the game object library, which should be enough to access the game object. It has it is written correctly. I'm not sure. Let's look at a different tutorial, find out why it doesn't work. So here in this tutorial we have class person. It has a private and a public section. Class employee. And then we have a class teacher, public person, public employee. So that's divided like this as well. I'm honestly I'm at a loss for words. I don't know. Maybe the problem is, are the constructors? Maybe? Are they? No, they shouldn't be. Right? You could override them. But let's just say the constructors were the problem, which they aren't. Yeah. So the wizard created that for me, which is strange that it doesn't work. Okay, let's see what happens. Okay, we have a class playership, that was fine, and then we want to have public of game object, and then it says the basically the class we're trying to inherit from is non-valid. Okay, object-oriented programming, error invalid base class C++. So, oh, that's we ran into that already. Okay, looking at game object, this actually strikes me if you know it. You are not allowed to have an array of undefined size. So, if we okay, so how are we doing this? Um, we could make a game object that has a protected point position. It has an outline, and we know exactly how many points it has. So we either could make it like universal, so we're just having a pointer there and stuffing it into the pointer. We could write a vector class from scratch, which is probably the least ideal to do. We could leave it to the objects themselves to define the outline thing. Which I'm going to go with, I think. Maybe not. So that's not what I wanted to do. So we're pointing to a outline array, to a GL float array. Okay, it doesn't like that either. Okay, so at this point um, I'm trying to come up with solutions for our storage problem. So what I'm allowed to use is OpenGL, GLFW, and the basic like Windows library. So what I'm trying to find out now is C++, the storage, maybe what's it called? Actually, a English word for it. Memory structure. So basically, what basically Windows.h defines what structures. Okay, it defines a coordinate structure. It actually does define a point structure, so we wouldn't have to write a point ourselves. Um, so type def. Okay, I'm currently reading up on the Windows.h. Okay, let's see what else Windows.h can do. Okay, it defines most of the data types. Okay. That doesn't seem to be all that much what we can use, so we could be needing to write our structure. For the moment, I'm going to go with the hard route of saying, okay, a game object only has a position, and then the game object themselves have an int which specifies how many. No, they don't actually. They don't. They have an array, a GL float array, which is called outline, and which has a size of 3 for the play because there are 3 points to be stored, like the top, the bottom left, the bottom right. So that's that. Then we're going to create a class for asteroids, which you can see the wizard. You can't see the wizard, which are calling asteroids class. I'm not too sure about the asteroids. I don't think we need to define separate classes for different size of asteroids. So we need to keep in mind that the asteroid is created with a certain size and a certain amount of outline points. But in the end, we could just scale it down, like move them inward so the asteroid gets smaller. And I think that is what asteroids, like the original asteroids, does anyway. There are like 3 or 4 different asteroid outlines, and they just get smaller if you destroy them. So we'll run with one asteroid class, and the base class is again game object. So what we're going to do here is again define. First, I'm going to look at an asteroid. Asteroid. And we're going to go with an easy one. And it has 1, 2, 3, 4, 5. Come again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 points for an outline. So we're just going to roll with that, actually. We have, again, a private and a GL float, and it has an outline consisting of 10 points, 0 to 0, 0 to 9, 0 to 9. And that's that. Okay, the next thing we need to do is we need to register the player ship with the game controller. So that do we though? Do we need to register the ship with the game controller? I do think so, because we don't want to have an input from the player, and then give that input to the physics handler, and then have the physics handler turn the ship. That would be kind of stupid, I think, because it's not part of the physics handler to, don't know, handle input. But it is kind of the part of the physics handler to turn to move and influence the system. So I'm really torn here, in the sense that the physics handler probably needs to have the ship as well, because you need to calculate the impulse given from alpha, the amount the ship has turned. I'm not saying it is the right thing to do, but I think we should still put it into the game controller. So what we're going to do is we have a public function that's that has no return and has set player ship, and we're going to have a player ship pointer to. We're just going to call it pointer. Okay. And we're simply going to put a pointer here, which we didn't already do. That's great. So we will basically have a we're going to call player, and we're just going to set a player is pointer. So we now have successfully registered the player ship with the game controller. So if we were to have a user input, we would then we would then directly influence the direction of the ship. Okay, so rendering the player ship is currently none of our business. Um, Game board, move the player ship, create class for asteroids. We had that already. Okay, projectile. So we're just going to create a base class for projectiles, and we're going to add a lifetime. So basically, we have a hmm. We're going to call it projectile class, and we're going to go with a game object. So what we need is size to lifetime, and then we will have a get lifetime, and we will have a do we need a destructor, like a delete method? Don't think so. Okay, we don't need it. So what we're going to do is we're going to have a so we have a lifetime now, and we can get that. And I'm just going to mess around with some stuff because we should be able to do this position. That's great. And look at our game object. What else do we have? We have a set position and get position. That's great. That works just like I expected. Okay, so we now have a projectile class when we can get the lifetime, and on creation we have a main, and in the main I'm going to define projectile lifetime, and we're going to have 60. Because let's just say we're calculating 20 frames per second. That would be 3 seconds. So basically you shoot and it goes 1, 2, 3, and then it ends. So that's kind of nice. We could say something like 80 for instance, to just this is a number which we can change anytime. And the thing why I'm putting it in the main is because all these defines we will put in here like how big's the window and everything. This one should probably be a define. We will make that a define sometime, maybe, possibly. At the very end, clean up and defines. So we have a credit lifetime, and you can set that, and in the main it's defined, so you can change it in one place, and everything else stays the same. So when it is created, the lifetime will be a projectile lifetime, which is 80 in this point of this case. So what else do we need? We need to use the user input from the main. Yep, we need to render the player ship. We need to use the game board, which we created to translate object movement onto a sphere. We need to move the player ship. Yes. And okay, one thing I think we forgot: player ship. Yeah, we forgot. It has a float and it's called. Don't know. What do you call it? Direction? I don't know. That's kind of stupid. We could call it angle. Simply angle. So we're just going to go with angle. And we're going to have a a public, which is turn left and turn right. Okay, now we can turn it. So basically, if we have in the game controller, we had a function for the input, we would do something like while we would make a switch. So basically, when the player presses a key, the switch goes to true, and if the player releases the key, the switch goes to false. And we have that for every control key, like every key that is used to control the game. Because if you don't do that, what happens is you press R, and R is being accepted once by your application, and at some point, maybe a second later, Windows sets in auto firing the R key. Like you get one large delay and then a lot of R's with very short delay. You can try that out if you go into any text document and just press one key, for example an F, and you will see it types one F, and after a short pause it will type a lot of Fs. So we don't want our ship to feel like that. We don't want it to turn a bit and then start turning. We want it to turn very smoothly. So we will do a switch that is set to true if the key is pressed, and it will be set to false if the key is released. So while this thing is true, it will turn. There will be no delay and no offsets and no pause, and it will be magnificent. Just like my English. Kind of. Okay, so the next thing is collision, which is very heavily dependent on the stuff that I explained at the start of the video, that I'm currently designing a vector class that I need to implement. And a huge part of the collision system in our physics handler will be checking vectors for intersections. So if every vector that makes up our our asteroid, it has no point of intersection with the vectors that make up our player ship, then there's no collision. That's the idea that I'm going with currently. Okay, asteroids destroying. So currently an asteroid has no lifetime or something else. So what we're going to do is we have a we're going to create a custom enum, I think. We have a enum called asteroid size. And what we're going to put in is, oh god, that's the wrong one. And what we're going to put in is a asteroid big. No, that won't go with the asteroid. We're going to big, middle, and small. And then we have a private size. And you need to create that. So we have a custom constructor. That says size is S. So basically we're saying our size is S. So if you want to create a big asteroid, you can have a big asteroid. If you want to have a middle, you can have a middle. If you want to have a small one, you can have a small one. And in that constructor, we will need to define the outline, independency of the parameter that it is created with. We could have done that as a float and scale it with a float, but I think that's overkill. But on the other hand, it would be really cute because you don't have to switch case for the enum. You could just have a static thing. So I think we're going with that. I think we're going with that. That's a really cute solution. So we have a float size, and we have a float size, and we have a float s, and we're just going to scale it. So we have here define asteroid outline factoring in size, or yeah, that's fine. Just call it factoring in size. So basically, if you make the size double, if you double the size, the asteroid bit will be double the size, which is amazing. Sounds very simple. It's amazing me. It's amazing to me. Okay, so let's have another look at our game controller. The to-do list here is probably not the most efficient and sensible thing to do, but it works, I guess. So asteroid destroying, we're not going to bother with that yet. Text, lives, points, and high score. We will need to make those from scratch, and they're not really essential to gameplay. You can play the game without instructions or a high score. Maybe even without lives and points, because it just doesn't have to be displayed. It could work internally. So that has like no priority. So we have, I think, most of the legwork done. And in the next part, we're going to create the vector class and its functionality, and probably get to user input. That's the current timeline I'm heading for. So thank you so much for watching, and I guess I'll see you in the next part. Take care.